Okay, you already saw this, so you don't have to watch it again. Here we decide which way the compass is going in each situation. The compass is determined the same way we talked about before, which is however northy goes, the magnetic field goes, the compass goes. They all go the same. You can probably hear you breathing playing. Be quiet over there. So you put northy at each location and see where it goes. First one, northy goes towards the south. Northy goes away from the north. That's easy. In fact, you could do the same thing over here. Northy goes away from the north toward the south. So the compass will point like that at those locations. Those are easy. These are a bit harder. Here you would say, all right, well, northy is driven away from this north, but it's also pulled toward the south. So really, this is a vector field, so you do a resultant. The resultant of these two, if you want to, you can redraw head to tail. The resultant would be start, finish, directly to the left. Up here you get something similar. The north pushes off at an angle, the south pulls down at an angle. The resultant again of these two is to the left. So it's, let me recolor it, the blue arrow is what the compass would look like. Now if you come over to this situation, the horseshoe magnet, same thing. The north pushes away, the south draws it toward. The resultant of these two is to the right. So you get an idea of what the field looks like around the magnet. Two notes. Note one, magnetic field lines never cross. So when you're about to draw these lines, don't ever have them crisscross. In fact, no field lines ever cross. A little extra credit is why. Think about contour lines from earth sciences. Next, the closer the field lines are to each other, the greater the magnetic field strength. So you have not drawn the full lines yet, but you're about to. Wherever they're bunched together, it's a very strong magnetic field. Where they separate, it's getting weaker. Please don't let them cross each other. Okay, so here we go. Question 7, let's do these. And we're actually going to go look at each of these in the back, live in person. Alright, we're doing question 7. You guys haven't done this yet, so look up. First thing you can do is line the side of the magnet. I'll put 4 northies over here. I'll put 4 northies over here. And the question is, where will they go? Burn, where will they go?
He said Guatemala.
I don't know the first thing he said.
To Guatemala?
Guatemala? What's the capital of Guatemala?
Guatemala City.
Oh. Is it not Guatemala City?
Yeah, it is.
Yeah, that's okay. No, I was thinking of Honduras. You remember Honduras?
The
It's
T.
Oh,
Yeah.
you guys are good. Good. Alright, so that's northy go right here.
Away.
Yeah, northy's going to go away in all 4 cases. And of course, over here, northy will come toward. The question is, how do they connect? And this might be a nice way for you to draw it. If you ever have to do this on a test, or they ask you to draw 4 field lines, it's difficult to do it and not crisscross them by accident. So if you set it up like this, you take the lowest one, it will actually loop around, and connect over here. You take the next one, a loop around as well, connect this way. That's an easy way to avoid crisscrossing, because sometimes what you do is you come too far with it. Around the top, you have the same issue, the north to the south, and in fact, bigger spacing, north, south. They won't ask you about what's going on within the magnet, but within the magnet, there's actually a continuation of these field lines. They actually go straight through. So within the magnet, this works a bit opposite what we talked about with northy. And really, it's not something for you to worry about at the moment, but there is a field within it, and it will point straight through. It will continue the field lines. Alright? Nice big mess. Unfortunately, it'll probably overlap with some of these others. So we're going to look at each of these live and in person in a moment in the back of the room. So let's try it over here. Let's put northy a couple places over here. We did this up top. we looked at the horseshoe over here, you probably get the idea. It comes out from the north, goes into the south. It does. So you get something like this. The arrowhead can be in the middle of the field line. The end of the field line really doesn't matter. Same thing over here. What about if northy were directly in the middle of the ends? How would it go?
South.
Yeah, direct, north to south. In fact, you get a little curving here, north to south. And even this gets wider and wider, but we don't need to color up the whole picture. Let's do these last two, then you're fully equipped to do W10-1, that's the homework. And we'll look at them with iron filings in the back. Okay, here we go. First one. If you put northy a couple places here, what do you expect?
You go straight to the left.
Yeah, it goes directly from north to south. As you move away from the center, they start to curve a bit. So in the central region, it'll go north to south. And even here, sometimes you don't draw the whole field line, you just draw a piece of it, north to south. But there's conflicting interests here. Do you see? At some point when the field line leaves over here, what south might it prefer? Might prefer its own. So in fact, at some point you're going to get a turning back of the field lines towards its own south, which ends up being nearer to it. So we'll see. We're going to go on the back and see if we get an image kind of like this.
Wait, why would it be going towards the north?
Oh! Good Lord, did I mess that up? Ugh. Switch the arrowheads. Thank you, Bill Brown. You are paying attention. You are paying attention. I think I messed that up this morning.
The eraser's on.
There we go. Sorry about that.
You messed it up.
You did it.
Oh, I messed it up. Holy cow. It's just, woo! Retake! There we go. Okay. So you get some business. And we'll see when we look in the back how this looks. Okay, what about this last one? Put north direct in the middle. What's going to happen? Nothing. It'll sit still. In fact, this doesn't look very different from the electric field between electric charges. If you go a little bit off to this side, you get a strong push this way, and this one gives it a little push back. This ends up curving up. So this shape probably looks a bit familiar to you. Remember something like this? You put two positives or two negatives near each other?
Yeah.
And in fact, eventually all this business will loop back on itself. And there you go. So, come around back. Come on, video person. Make sure. We're going to look at each of the scenarios here real quick. On the overhead. Now, here with the overhead, you cannot actually tell north-south. What we're going to do is we're going to take iron filings. And iron filings don't have little heads on them to show you whether it's north or south, pointing toward or away. But they can give you the general direction of the field. So what we're going to do is get the general shape, rather, not direction. They give you the general shape of the field. So the first thing we'll do is what we had up top, which was just a regular old bar magnet. There it is. You dump the iron filings on. You can show them what we're actually doing here too. And what you'll start to get is the iron filings will arrange themselves along the magnetic field lines. So you can't tell in or out, but you can tell that at least the general shape is coming out of one of these ends and into the other, all the other way around. But you get that shape. Turn around, show the board again. On the top left.
Oh.
You're getting that approximate shape.
Same shape.
There you go. Now if you look here, we're doing everything in 2D. If you get down low and actually look at the filings themselves, you see they're standing up because this is, magnetism is 3D. We're drawing everything 2D and projecting it. This is also happening up above the magnet. The next one was the horseshoe. Here's the horseshoe magnet. And so what we're hoping for is some connection between the two ends. And so let's see if that actually shows up. In the middle, it looked like it went approximately straight across. And then, as you come down near the ends, you have that curving between the two ends. Are you seeing that? Alright, so this one should give you an approximate look like what you see on the top right on the board. Curving between the ends. And it does. Now let's try the other two, and then we'll stick the big boy on there. You'll see it's pretty cool. Alright, so here, if we want to set this up as it is on the board with north-south, so they're attracting each other, we set these in the orientation that they attract. However, we want a little gap between them. So we'll put the protractor here. It'll keep them separated. Try not to get too distracted by it when you look at the board. Hang on 1 minute. So do you see it's going directly between the ends, and then you get curving around it. But as you move off to the sides, you get the interaction of the two poles of the magnet itself. So you should get connecting, and then out on the sides. If you turn around, that should look like the picture on the bottom left. Does it? Not all the way to the left, not that thing in the blue shirt. The last one, that gentleman. The last one is the repulsion. Now repulsion, I don't have to put a spacer in there. In fact, they try to get away from each other. I don't really want them to. So we'll dump this on here. And what we should see is that there's a gap in the middle, and in fact, it forms pretty distinctly. They really don't want anything to do with each other. They interact with the magnet interacts with its own pole. When it's connected to it, and you get that gap, that space in the middle. Even when I throw them in there, you see they get pushed off. So that one should look, they interact themselves, which you get a pushing out in the middle. You turn around the lower right, should look like that, and it does. Last one, if you have a minute to look at it, you'll like this. This is the neodymium magnet. So we'll look at it. This is set up north-south. Here I can't tell which is which, but it's the face of it that's one pole. And since the field is so strong here, let's say if this were the north, it's coming out of it. This will actually hold them to, you can see even coming out of this, it comes out funny. But this will hold it in quite a three-dimensional structure. So we can literally hear, it's like making a little magnetic chia pet or something. So the field lines definitely do come out in 3 dimensions, and if you have a strong enough magnet, it's easy to see. Yes. So this is pretty cool. You continue to dump it on. Now at some point, the gravitation, if you move far enough away, the gravitational field, or the force due to gravity on each of these is about constant no matter where you are. But if you get far enough away from the magnet, the magnetic field strength drops off, and eventually gravity wins and they start to fall over. There are 2 things to keep track of here. One is science, which is the magnet is attracting the filings. So what will the filings do to the magnet? Newton's third law. And of course, the magnet will stick to the bottom of this no problem. It would have done it with the smaller magnet too. The second is just fun. You can just kind of comb this.
It actually flat.
It does. It's got a nice feel to it. And it's good now because it's so interested in the magnet, it doesn't really stick to your fingers. Normally,
I gotta do that demo. That's cool.
Yeah,
I'm sorry to talk over you.
That's all right.
Actually, I should say that's my demo.
We could do one last one if you want. You got a minute?
Yeah.
All right. This is a little annoying to take off, but can you get it?
Put it in here.
Yeah.
No. Bend it. That's not
That's all right. This one. See if we can actually connect to the 2 sides.
Oh. I just point it out.
Leave it on there. So the north and south now can access each other. There's no overhead in the way. You see that's intense going straight through the middle of it. Can we get anything? Let's see if it builds it up. Oh, wow, it's actually folding the overhead sheet.
I'm sorry. That was not showing. We're folding it down.
So you're really getting a strong...
And you can see the wrap feel. So.
Yeah, it's wrapping right around it. And this one will build up quite a bit. That looks like some sort of weird roach or something. Does that bother you too? You dump all this in here. Just layers up.
Oh.
It's pretty cool, right?
Oh my god.
Give that a feel. Alright.
Go bar that period 5?
Yeah.
I'll do it again.
That's it.